Let us solve the exercise number 5 in the part A of data structure lab. In this exercise, we are supposed to write a program to search for an element using recursive binary search. So before we write the program, let us quickly recall what is binary search and in particular recursive binary search technique. Now, when we say binary search, the idea behind here is we are dividing it. Bi means we are bisecting the given list into two. A very important thing about the binary search is the elements that are given has to be there in the ascending order, or it can be also descending order also, but they must be in a particular order. So in this case, for example, you have the numbers in the ascending order. So the elements which are given over here has to be in the ascending order. What we do generally is we take the list and divide it into half. So we bisect it into half, and exactly at this half position we try to find whether the search element is available. If the element is available, our search is complete. If not, we check whether the search element, the element that we want to search, is less than this number or greater than this number. If it is less than this number, then we go to the first half. If it is greater than this number, that is the number which is there at the middle, we go for the second half. Okay? And if we go to the second half, we again divide it into half and we try to find the search element at the middle. If this is the search element, then our search is over. Otherwise, again we check whether the search element is greater than or less than this middle number, that is the number at the mid. If it is less, then we again go to the first half of this section, and then if it is greater, we go to the other half. So this is how we are going to do it. So let's try to search for an element 95 which is not present in this list. You know very well that 95 does not exist in this list. So how do we do that? Now assume that you are given this list, and this list consists of 12 elements. So starting from A0, A1, A2, A3 and so on up to 11 means there are 12 elements are there. We will mark the index location, that is the first index location is 0 and the last index location is 11. So totally there are 12 elements are there. So we add 11 plus 0 divided by 2. So if you have this 0 is the starting, 11 is the ending, that is the lowest index value is 0 and the highest index value is 11. So we divide this by 2. When you try to divide it by 2, you are going to get 5.5. Just take the integer value. So we go to the fifth index location. Remember, these are the elements which are there, but we are interested in the index value. So we go, that is the element, whichever value which is there at the middlemost. So what we notice over here is the middlemost element which is there at A5 is 60. Now we are interested in finding 95. You know very well that 95 is greater than 60. So our search will now restrict to the second half. Since we have already tested this element at the fifth location, we won't again include that in our list. So what we are going to do is we are going to say that our list will start from here, not the 60, because we have already tested that the 60 is not the search value. So we are going to do is we are going to start from the one element higher than this. So our last mid value was 5. 5 plus 1 will be 6. So the lower element now is, let me write this, low element, why this is coming like this? Okay, let me, where is the capital of, okay, low element is now whatever was the middle value plus 1. So middle value in this case was 5. 5 plus 1 will be 6. So middle value, now it was 5 here. So 5 plus 1, 1 greater than the middle value. So this is going to be the next low value. Now start taking this value. This is 6 and 11. Okay. So start the value. 6 is the lowest index value. Then 11 is the next, that is the highest index value. Bisect it by 2, that is divided by 2. When you try to divide it by 2, you will notice that this is equal to 17, that is 8 point something. I'm going to take the integer value 8. So our next mid is at 8. So I'm going to just keep this mid over here. So here, if you notice, our mid is now at this 8. What is the value at 8 is 90. And what is that we are interested in is we want to find 95 here. Okay, so 95 is greater than 90. So what we are going to do is we will, this is the first half, this section is the second half. We will restrict ourselves to the second half. So how do we do that thing? We will move this because we have already tested the element at 8. We will move the lower pointer to the next element. So what is the new value of a low? New value of a low is whatever was the middle value plus 1. What is the middle value here? Middle value is, in this case, the middle value is the 8. 8 plus 8, what is this? 8. 8 plus 1 will be equal to the 9. So our mid value was 8 here. So 8 plus 1 will be 9. So this will be our low value. Now this is your lower value and this is your higher value. Okay. So start taking those two values. So the lower value is 9. The higher value is 11. Remember, we are not interested in the element. We are interested in the indices over here. Divided by 2. So divide by 2. So this is 20 by 2, which is going to be equal to 10. So our new mid is at 10. So we are going to keep this mid here, 10. Now, so we are going to search for this element. The element at this mid is 110. We compare it with the 95. What we notice? 95 is less than mid value. So we will restrict ourselves to this area. So what is the meaning of we will restrict ourselves to this area is we are going to move our higher pointer. Now this time we used to come to this side. Now we are going to move the higher pointer to the other side. So how are we going to do it? So the new value of, let me do it, new value of a high is whatever is the mid value minus 1. The reason why we are doing minus 1 is we have already tested the value at the mid value here, 110, which is not equal to 95. So we will not include that there. We will reduce one, we will go one step on the other side. So what is the mid value? Mid value is 10. 10 minus 1 is going to be 9. So our new high value will be 9. So I'm going to move this over here. So now you notice that both low and high are pointing to the same location. Let us try to find the middle of this one. So the low value is 9 and the higher value is also 9. Let us bisect it, 9 by 9. If you try to do it, so the answer is going to be 9 itself. So our new mid will be 9 itself. So when I say 9, the element at the ninth location. So we are going to keep the mid here. So all of them are pointing to the same location. Now what you notice, the value at this mid is 100, okay, which is greater than the element that you are trying to search. So what we are trying to search is 95. So what we are going to do, we are going to move to the first half because it is sorry, this value is smaller than the element over here. So 95 must be somewhere before this one because it is in the ascending order. So these elements are in the ascending order. So 95, if at all 95 is there, it must be before this 100. So we are going to move to the other side. Now what we are going to do? So we are going to recompute the value of I. So how do we compute the value of I? You know very well. I is mid minus 1. So we are going to move the higher value to the other side. So what is the mid value? Mid value is 9. 9 minus 1 is going to be 8. So we are going to move the high by one level down. So we are going to move this one because we, if at all 95 is there, it must be there before here. So we are going to move this one. We will say that 95 cannot be there in this region. 95 is should be there before this. So let us try to move this high on the other side. Now what you notice here is 9 minus 1 is going to be 8, and it is what you notice here is this is contradicting. So what we have here is we are saying this pointer as a low pointer. What is the value of the low pointer? 9. And we are saying this is the higher pointer. And what is the value of this? This is 8. So this is a contradicting. So a high, if you say a low is 9, high must be something higher than that 9. But now you say that the higher is less than the lower. So this is a contradiction. Whenever you get this contradiction, we stop the binary search operation and we say that the value that you are trying to search does not exist. So this is the condition for saying that if the value of a high is lower than the low value, then this search is unsuccessful and this element does not exist. Okay. So now let's try to rewind and let's try to search for the element which is already there. So we know that mid of it is, so this is going to be here. Suppose if you are trying to search for an element 16, how do you find that thing? So first of all, what is the lower value? Lower value is 0. Higher value is 11. So 0 plus 11 divided by 2. This is 5.5. Let me take the value as 5. So index value is 5. What is there at the index value 5? At the index value 5, the value is 60. And what we are trying to search is 60. So we say that the element exists. So this is the basic idea. So if you find the element at the middle, if the element at the middle is same as the search element, then you say that the search is successful. If not, then we check whether this element is less than. If so, go to the first half. or greater than? If so, go to the right hand side. And what is the terminating condition? Terminating condition is where the high value becomes smaller than the low value. So if you get the higher is lower than the low value, then we are going to terminate. This is the essence of the binary search, and we are going to write that binary search now. So let's go ahead and let's start with the binary search. So I'm going to go to the code block over here, and I'm going to start a new project. I'm going to click on this one, and I'm going to say new file, and I will select C and C++ source. Let me click go, and let me click next, and I will select C as my project, and see to it that you are saving it in proper location. So this my caps lock is there. So by search. Okay, you can give any name, but to see to it that you don't give the spaces in between the name. Just click finish to finish it off. Let me start with the include stdio.h, which is generally required for our input and output operation. So this is there. Let's first write the function for binary search, because it is going to be a recursive search. So I'm going to say, you can call it anything. I'm going to say B search. Okay, or BI search, anything. Okay, we need, what are the things we need? We need a, where is this thing? This is not required. Okay, what is this? We need a list, a array. Definitely, we need an array. So that part is there. Let me call that array as A. And what else we need? We must know what is that we are trying to search. So without this, there is no point in doing anything. So I'm going to call this one as key, that what we are trying to search. So let me call it as a key. Okay, and you must know the two pointers. Which are the two pointers? So the two pointers are one is high, and the other one is well, let me just put it here. One is this pointer, that means the starting point and the ending point. Mid, we will calculate it. What is mid? High plus low by 2 is going to be the mid. So high is low is 0, high is 11 by 2 integer value. We are going to get the mid value. So we need two things. One is let me say low, and the other one is high. Right, done. Okay. So what is the thing that we have to calculate? We have to calculate the mid, is it not? Okay. What is the stopping criteria? First thing is, what is the stopping criteria? Stopping criteria is when the high goes below the, or when the high is lower than the low, you just stop it. So this is the stopping criteria. We start with the stopping criteria. What is it? If low is, if the high is smaller, or if you can say if the low is higher than the high, so one and the same. Or if you say high is smaller than low, it one and the same. If the lower is greater than high, so it, yes, or if you say higher is smaller than, both of them, it is just a logic. Okay, then I don't need the flower bracket here. Then we will say that the search is unsuccessful. So the search is unsuccessful. How do we say that? We are going to return -1. What is the meaning of saying -1? You look at this array. What is the starting element of the array? A of 0. Index value is 0. What is the index value -1? Index value -1 means there is nothing is there. We are coming out of this array. So -1 means it is not there in the array. So it that index location is not obtainable. Okay. So that is the, so we are going to return it. So there is no point in doing anything. If the low is higher than the high, then we are going to return it. Otherwise, we will calculate the mid. How do we calculate the mid? Mid is, as I have told you, high plus low by 2. Okay, all of them are integer. This is integer, this is integer. So integer divided by integer divided by integer, you know very well. In C, you are going to get the answer as integer. If you divide integer by integer, division is integer. What is the thing? So if you are very lucky, like in this case, the minute, let's say this is the low and this is the high. The minute you find the mid, how do you find the mid? High, low plus high, or high plus low divided by 2. So if you are luckiest person, the mid value itself will give you the answer. So if the value at the mid is equal to the search element, that is the key, then your search is over. So this is as simple as that. So if A of mid is equal to the key, that means you have found the element. So in that case, it is all done. So you are going to say return the mid value. You got the element at this location. In this case, for example, the mid is a plus high plus low by 2 is this mid, and this mid value A of mid is equal to the search. That means you have found the element at the index location 5. So that is what you are saying here. So you have found the element. Otherwise, what are you going to do? Otherwise, you have to either go to the left side or right side, depending upon whether the key is less than or greater than. So if okay, the value, if the, for example, let me just tell you, if this value is 40, search value is 40. So you found the low and high divided by 2, you got the mid. So this mid value is not equal to the key that you are trying to search. Then you compare whether this is less than the mid value. If it is less than the mid value, then if at all 40 is there in this list, it must be in the first half. It must be in this region. No, it cannot be in this region because it is in the ascending order. So it must be in the first order. So how do you write that thing? If the key value is less than A of mid, then you are going to recursively call the same function, binary search. You will call the same, you will perform the same operation. You will send the array, you will send the key, but you are going to change the, you are going to keep the low value as it is. You are going to keep the higher value as mid minus 1. So what is the meaning of this one is if you are searching for 40, if you are searching for the 40, you found the mid value, and what you notice that the value at the mid is 60. So you are going to confine yourself in this region. That means to say that you have to move this high pointer before the mid. So why not keep at the mid? Because the mid is value is already tested, and we know that it is not 40. So we will keep one step before this mid. So mid minus 1. What is the value at the mid? Don't worry about this one. We are not interested in this one. This mid is referring to this index value here. So 1 less than this index value is 5 here, 5 minus 1. So this is pointing to the value 4 here, not the 40. This high is pointing to this index value, not the actual value which is there. Okay. So we are going to say mid minus 1, 5 minus 1. So this is the case. There is one other case that we have. What is the one other case that we have? The other case is, let me go over here, is what if you are trying to search for 90? Okay, so let's start from the beginning. So you have the low and you have the high. Okay, and you found the mid, and what is the value at the mid? Value at this mid, which is the fifth location, that A of I is 60. You compare it with the 90, it is not equal. But what you notice that this key is higher than the mid value. So what does this mean? If at all this 90 exists, it must exist in this region. It cannot be available in this region because all these elements are in the ascending order, and they are all less than 60. So what you are going to do, you are going to restrict yourself, or you are going to constrain yourself for this region. How are you going to do that thing? You are going to move this low pointer and you are going to keep it here. Why not at this location? Because this is already tested. So what you are going to do, low is 1 more than the mid value. What is the value at the mid? 5. 5 plus 1 is 6. So we are going to say, otherwise you move the lower pointer. So here we are going to say, otherwise you do the same binary search operation on the same array and on the with the same key. However, the low value, remember, the first one is the low, second one is the high. In the previous case, we moved this high value by one step down. Now we have to increase the low value by 1. How can I do that thing? I'm going to say low value is mid plus 1 and keep the high as it is. So either you increase the low by 1 or you decrease the high by 1. In any case, you do this one. So this is your operation that you are going to perform in the binary search. So this is your binary search algorithm. Let us write the main function. I'm going to just write the main function. I'm going to say void main, okay, void main, and let me write this one. What are the things that I need? I need an array, let's say a of 25 elements, and definitely you won't write more than 25 in the examination. Even though you are allocated for 25 in the examination, you will go for n. Generally n is 5 elements, so you restrict yourself. Because it's an array, you need a for loop, and for loop requires a loop counter, and that is I. You need to search for the key, okay, that is required. And this is going to, if you look at here, this function, if at all you are going to call this function, it's going to return the position where you are finding the element. In other words, it is going to say whether your element is there at this location or at this location or this. It's going to give you the index location, that is the position where the element exists. So I'm going to keep one more variable called as position, where I'm going to get the element. Okay, so let us start with the printf statement, and I'm going to say printf, and I'm going to say enter total number of elements. Okay, now some of you are so you during the examination you just forget what is the binary search, what to do anything. Remember, if you have an array, okay, you will search for n number of elements and you will insert n number of elements into the array. So how do you insert n number of elements? First you ask what is the value of n, accept that n value and enter the value into the array. So you do that part, you will get the marks for that, whether you know this part or not during the examination. If you forget it, but you know that if there is an array, you generally ask this question, enter the total number of element, and you are going to read the value of n. So this is true for almost all arrays. So you just write this part. Forget about the binary search if at all don't know. Suppose sometimes happens when you are worried much, you are going to tend to lose the information in the brain, so brain just stops functioning. In that case, you know how to enter the element into the array. So I'm going to say enter, okay, n number of element, whatever n you have said, n sorted element. Why did I use this sorted element is, you know very well, if at all you are using binary search, the elements must be in the sorted order. You cannot try to do this kind of suppose if 60 if 20 was here, 60 was here, this will fail miserably. It will confuse the binary search itself. Now, in the middle, the value is 20. So it will start searching in the left hand side or right hand side. You will confuse it altogether. So don't try to do that thing. So the whenever you are entering the values, it must be in the sorted list. Only in the sorted list. That is one of the disadvantage of binary search, and more about it in your theory classes. I'm not here to talk about your theory classes, so I will not bore you with that. So let me get that thing. Then we have a for loop. Where is it gone? Let me put this one for loop here. So for I is equal to 0, these are familiar things with an array. Whenever you have an array, you have a for loop. I plus plus. These you cannot forget after typing it so many times. You can't say that no, I don't know that. Okay, so this is there. It will automatically come. Write this much during the examination. If at all you if at all you forget, just write this much. Accept the element into the array. That is all. Accept the element into the matrix. You do that part. You will be given some marks. Okay. Now start doing this binary search. Remember, whenever you search for the binary, I told you this binary search will return the position where the element exists. So I'm going to say whatever is returned by the binary search, I'm going to store it in this position, and I'm going to call this one as a B search. And what are the things I'm supposed to supply? I'm supposed to supply A. I'm supposed to supply. Oh, sorry, I not done that part. Let me one important thing. I have not asked the user what is the element to be searched. Sorry, let me type that thing. So no, when I talk, I tend to forget the thing. I'm going to say enter the element to be searched. Now, the funny part is if this is not there. So this is what I was doing. If this is not there, what are you going to search? If the search element itself is not there, what are you going to search? Okay, that is the most funniest thing. Okay, in any case, that happened. Let's complete this part. Then I'm going to search for the key. So key is the one that I'm searching. Key is something that I want to search. Key element, that is the element that I want to search. Now let's start with the binary search. You know very well, binary search will return the position, and I'm going to store that position here. And what is the name I gave? I think I gave the name as B search. A is my array, so I created this array. You notice that I created this array A. Okay, and next one is the key that I'm trying to search. Look at this one. Next one is key. Lower value. No, in the array, lower bound is what is the lower bound of an array? 0. You know that. Lower value is 0. What is the higher value? If n is 12, what is the higher value? N minus 1. Because we are starting from 0, it is 1 less than this. So n minus 1. So this is going to be n. So if the starting one is no problem. You know that array will always starts with the 0. The highest index value is not 11, it is not 12, it is 1 less than 12. You know very well. If n is 12, it 1 less than that. So I'm going to just say that thing over here. This is n minus 1. What is n? Total number of elements. So if the total number of elements are 12, 1 less than that, that will be the value of n. So done. Done with this. We have done. Now let's try to print it. So if you know very well, if the element is not found, if the lower is greater than the high, that means you're going to return -1. If it is not -1, so if the position is not equal to, let me put it here, -1. So if the position is not equal to -1, you found the element. You're going to say print f, and you are going to say element is, or you can say key, anything, key is found at, or anything, element is found at percentage d. This is the position, at this position, or at this location, at this position, whatever you say, at this position. So what is this position? Position is this. If you write a position is this, people, not you, will not get confused, because you know that how the binary search is working, and you know that in a C program the index always starts from 0. So you know that. Now you may say that the element is found at this position, which is this position, position number 5. But the person who is studying in high school will start saying this is the first element, this is the second element, this is third, fourth, fifth. What is there at fifth? Fifth is 50, but I was searching for 60. So it is not. So you know very well. For the world, they started counting from 1, but C is not the world. So C starts counting from 0. So our counting is from 1. So whatever C is counting, plus 1 for that, to make it exactly with that thing. So it is a position plus 1, so that otherwise you will be giving the array index value. Array index is not asked. They are asking the position 1, 2, 3, 4, 5 position, like that. Okay. Else, you know very well. Else, this is the easiest part, I suppose. What is this easiest part? You're going to say element is not found. This is one of the easiest one. Okay. Done with it. Done with it. Okay. Done. Let me save it and let me run it. If I not done any mistake, it should run. If it is not running, if it is not doing anything, that means I have missed something. So in the examination, you click on this one, nothing happens. So what are you going to do? You will not, don't get scared. Click on view and just go to the logs, and you will find that you have done something wrong here. I have typed print F instead of print F, I typed print. So it happens, okay, with everyone. And again, there is one more print. Where is this print? Okay, one more print. It happens with you, me, and the rest of the world. It will happen, so don't worry. So total number of element is 5. The first element is 10, 20, 30, 40, 50. Okay, 5 elements. I'm trying to search the element number 30. So element is found in the position 3. It is saying position 3. So count the position. This is the position 1, this is the position 2, this is the position 3, and I found it there. So done. Let me run it one more time. And again, I will say total number of element is 5. You know very well, during the examination, you don't go beyond 5. Okay, unless and otherwise you don't have anything else to do. Okay, so 10, 20, 30, 40, 50. I want to search for 25, which is not there in the list. I must get the answer as element is not found in the list. That's all you are supposed to do. Thank you for your interest. We will meet again in the other exercise. Thank you.